Hello, welcome to Faux Spring Break, Suffolk University 2021. I am Professor Scott Lucier. I'm going to give a talk here about cartography, one of my passions, one of the things I really have been getting into lately. Just enjoy the whole art aspect of what I do, and I'll explain that in a minute. But we're talking about, typically the definition of cartography that we teach in university level is the art and science of map making. We're going to focus mostly on the art here. So what's my background? I'm an environmental analyst by training, been doing environmental work for, I don't know, 30 or so years. Took my first map making class as an undergraduate down at URI a long time ago. But I've been teaching map making at Suffolk for a dozen or so years, maybe a little bit longer, in two versions, one designed for environmental majors and one designed for non-science majors, and do some other stuff as well. I'm the map guy, I'm the drone guy, love that as well. I've worked at many levels. I've worked in consulting. I've worked obviously at Suffolk at the university level. I've worked for nonprofits. I've worked on my own one-man consulting shop making maps. Centered mostly around the engineering world. So that's me in a nutshell. And this is what I do. This is a program called Quantum GIS, QGIS. Another version is the one you've probably heard of more popular is ArcGIS, Esri, ESRI. And basically what I do is I make maps. Here's one I've been playing around with lately of Nantucket, some lighthouses. Been playing around with these water lining, concentric circle, kind of a late 1800s style that I'm trying to master on a computer here. And this is it. This is, a lot of buttons, a lot of power here, very expensive, powerful software that we teach our students at Suffolk because it's something that environmental majors, environmental employers are looking for in our majors. So we teach our students how to use GIS software, geographic information systems. And this is kind of a pretty map, if I do say so myself. But really, this is what the guts are behind this map. Here is what we call the attribute table. This is the 3,829 minor roads in Nantucket and all sorts of data about them. I've got all kinds of columns showing everything you ever wanted to know about the roads in Nantucket, the minor roads. All right, so this is the guts of any GIS system. We try to. This is where all the power comes from. This is where I can start to do calculations and ask questions of the data and pull out information. And I've been doing big data for 30 years. Like GIS is big data. We use massive data sets. When I was a consultant, I worked for National Grid. We had every electric pole in the Northeast, New York and New England, on a GIS system that we had to work with. So it was massive, and that's what this is. So this is a smaller version of that, just Nantucket, but this is the guts of it. This is the important part. Data is everything, and that's what I've been preaching to my students for as long as I've been teaching. Right, that the data is the powerful stuff, and that's really what matters. And the art part is just the it's nice, but not a big deal. Here's that same information. This is in ArcGIS Pro, the latest and greatest expensive software, showing all tree data in Boston. So urban trees. We like to keep track of urban trees and their oxygen production and carbon dioxide uptake and shading capabilities and the impact on the economics and how property values rise if there's a tree line street and the maintenance records and all of that good stuff. You think you just see a tree when you walk down the street in Boston. I see data information about that tree. It's very important. There's a lot to it. And my engineer brain kind of goes right to there, but it's also pretty to look at if you get right down to it. But that's what this shows, right? So I can't see 7,188 trees the location, the when it was planted, the type, the genus, the species. And we could also do some pretty cool analysis, right? We can then say, okay, of all these trees, we've filtered 5,662,059 gallons per year. And what do we got here? 3,960,626 kilowatts per year saved, or $220,912. Very specific data, right? Like, that's a little crazy. Where do we get this information? We can do things like this with a GIS. It's seems very accurate, like hyper accurate. Obviously, we don't really know exactly, but at least we can get close to that, right? We can enter in what's important to us and the values of things into a formula, and then have it shown on our database. Like, get information like this, or draw a picture showing those values, and that's the cartography, and we're gonna get into that next. But pretty powerful stuff. Like, these are the eco benefits. Pretty powerful, good stuff. But let's dig into the cartography a little bit, right? So let's say I have those trees, I can color them, and make different shapes and symbols and sizes and labels, and that's what the public sees. That's a picture tells 1,000 words, right? A map tells 1,000,000, I'd say. Just very powerful medium, being able to see something, see the colors, and interpret that. And it's very difficult, right? It's a very different skill set than the data stuff, right? The database management stuff that is so important. You can do some amazing analysis, but if you can't communicate that to your audience, it doesn't matter. And art is a big part of that, like making the viewer feel like they get it, they understand it, it's pleasing to look at. And that's where we're going to transition into now. Leave all that data stuff behind. Here are some examples. A lot of examples here are from a gentleman named John Nelson, who works for Esri. I believe he's from Michigan. He has a great blog, and he's very great about sharing how he does things, and he's educating the community quite a bit. Here's Germany in a couple different styles. Sort of a Swiss style. They're beautiful, right? But they're real data. This is real elevation data on the right there. They call that a Tanaka contour style. Same exact information, but we can style it up many different ways, and that's what a GIS system can do. These days, here is Switzerland, right, showing the light. The Swiss know how to traditionally know how to show light, how to paint light. This is, again, real data. Real cities are exactly where they're supposed to be. The mountain elevations are shown properly, but it's beautiful, right? Like, you don't think of this and say, okay, this is a hardcore engineered map. This is art, right? This is beautiful. You can get playful. Here's a cross stitch pattern with buttons and stitches of the Great Lakes, if you want to. But again, still real data, still accurate. If you put the real data underneath that, you'd be able to pick things out. Here is obviously the United States, kind of a natural Earth, but you can see that there's texture to it that the oceans don't really look like that. But the real beauty of the natural landforms are just coming out very clearly. I could look at this for a long time. It's great job. Here's another one, Hasher style, I believe. I kind of forget, but you can kind of lightly see the contour, the bathymetry depths of the lakes there, and the contours of the landforms poking out there a little bit. But again, more art than it's real data, it's real science, but there's a lot of art to it. And this one's called the tattered map sandwich. So you want to make a pirate map. Here's a good style, and you can save this style and apply different data layers to it and do lots of stuff. But you can get pretty whimsical and creative these days. It's fun. Here are a few. The one on the left is a reproduction of an old classic map of a gentleman who made the map of South America, sort of highlighting Brazil, which is kind of dominates South America, but recreated in ArcGIS, and real data, real very accurate, great stuff. And then another example of uh, Panama, excuse me, and a different perspective, kind of an angled, oblique perspective. You got the inset map on the upper right. A lot of little details, and it just looks like you're sort of hovering over a map, and it's well done. Here is Alaska, drawn up in a Lord of the Rings style. If you look closely, you'll find Mordor. Not really. You might find Anchorage, actually, but we can apply Tolkien style onto real map data. This is real map data. Those mountains are right where they're supposed to be, but just kind of fun. Here is an old map from George Washington on the left. Is that he was a surveyor, map maker, and that's his actual. He drew that map of his Mount Vernon, his farm, and we've taken that, and we can take those styles, those colors, those lines, and put them into our geographic information systems and draw out maps on the right, which is actual real data from today, in a similar style. So it's kind of neat. Here's another one. This is, again, real data, actual building locations of today, but Waterloo, Ontario looks like a map from 100 years ago, but really it's new data styled up. So there's a lot, and it's, again, very pleasing. Like I want to sit and look at this a little bit. This is neat. Here's just a chalkboard, another fun one. Kind of the Craigslist areas. When you go to Craigslist, these are roughly the regions that are shown there. So every semester I'm face to face with 30 new students. We have a very diverse and international university. We have students from around the world, and we have students from the design school and the business school and my environmental students, and we have a wide range of backgrounds coming in, which is great. And then what do? My job here at Suffolk is and I say, well, this is what we're going to do. We're going to learn about data. We're going to learn about accuracy, and we're going to do one section on cartography and the art part of it. And I'm rethinking that a little bit lately. But we have all this great technology and the internet and web maps and just data coming all over everywhere, coming through the internet, and it's fantastic. It's great. I love it. But my focus is always on the data, and my students will tell you that. He's always prattling on about data and how difficult it is and how it's important and all that. But so it's tough. We're my engineer's brain kind of takes over. So but here are the kind of the three things you got to talk, think about when you're making a map. Like, follow established cartographic rules, conform to how the viewer's brains work, and then use the technology. So we'll just run through these real quick. Here are the rules that I preach. Don't worry about it. We're not gonna go into all this, but there's if you want to pause it and look at those, if you're really interested in map making and GIS, feel free. But like I said, it's a lot about data and accuracy. Not always out there in the world. Here is Hong Kong in South America. Not quite right. Here we go. Egypt. The border of Egypt and Iran is a hotbed of activity these days. Not quite. Here is another map of solar irradiance. How hot is the sun? And you could, there's a lot of data here. There's a lot of people going out testing the sun over the course of a year, doing probably some computer analysis to make this. A lot of data, a lot of information got you to this point, but I can figure this out in about half a second, right? Yeah, Arizona, Southern California, Southern New Mexico. That's where you want to put your solar panels, right? I don't really even need the legend. Like I don't know what 4.75 kilowatts per square meter per day really translates into. I just know that the difference between Maine and Southern Arizona is vast, and so this is a well done map, a good example of that. Like, barely need the legend. It's there if I need it. This is a bad map. This is terrible. Everything from the projection, the Mercator projection, and I can't figure this out. It really just kind of annoys me, right? You look at this and you're like, oh God, really? This is work. I don't know what I'm seeing here. just, I don't know. You understand why, right? Like the colors, I can't really distinguish which colors are which. I've got, you know, very pixelated blocks, which if that's what it is, that's what it is. But overlaid on very specific county data that doesn't match up well, hurts my eyes. Here's another one that doesn't hurt my eyes. Like, this is kind of nice, right? So this is the popularity of certain musical groups at a certain time on Pandora. They keep track of, who's listening to what. A lot of musicians that I'm too old to really understand who they are. But anyways, map is nice. You look at it and say, oh, that's nice blues, right? Kind of cool. But I can't distinguish all those blues. Like, my brain can't process that. Maybe yours can, but there's just too many shades of a similar color there that I don't know. It doesn't work. I mean, it looks nice, but not so good. Here's one of, I guess this thing probably looks great on the computer when they made it, but translating it over to black and white, kind of a missed the boat there. Here's one. This is hate groups active in 2003. The map on top has got all kinds of different varying symbology, circles and squares, and I can't figure this out, right? I need to constantly go back and forth to the legend, and I don't know, like, what's bigger, a circle or a square? Like, it doesn't really make sense. The one on the bottom makes much more sense. The larger circles represent more hate groups, and I can make quick sense. I look at one glance at the legend. Okay, I get it. Larger circles, more data, and that works well. So lots of different choices that we make as we create maps. Here's a badly bad typography, bad fonts, bad label placement. You look at it and it's, you're just like, you're confused, right? You're trying to figure out what's what, right? Our brains we've come to expect certain things. The one on the right, you look at it, you say, oh, okay, yeah, makes sense, right? And you don't even realize what you're seeing. And that's the sign of good design, right? Steve Jobs. People shouldn't be held up by your design. It should lead them places, right? And that's what this does. Like, it makes sense. Okay, now I can figure out where's Pennsylvania, where's New York, where the ocean is, and you can get the sense that it's vast, and a lot goes into this. But as you can see, you got to make a lot of adjustments to get from the map on the left to the map on the right. So that's part of what cartography is all about, is that just placing those labels. It's time consuming, very precise work. Here's a bad map. This is called Fewer Kids: The Change in the Number of Children Under 18 from 2000 to 2010. And I look at the legend and I say a loss of more than 20%. You're talking about loss and more and percentages, and it's confusing. And I still can't figure this map out. I think that the reds, more kids are leaving, I think, but the fact that I still don't quite understand this is not good. But this was, USA Today probably accompanied an article, and it's tricky. One thing, the idea of layering in art and GIS systems, you can take many different layers of data, and that's the real power of it. I can take data from many different sources, put them together, lock them together on the common field of the geography, and that's where the power comes from, and using all this data. And we use different layers of data, and there's a lot to that layering. Here is a map of Kauai in Hawaiian Islands, popular vacation spot. If you can get there, it's a long way, but you could see the graticule lines on the top, and then you just put them underneath, lighten them up. These subtle little things that we don't really notice is all part of cartography. And we're getting into sort of more of the details, like the scale matters. We have here a 1 to 10,000 scale map and a 1 to 50,000 scale map showing the same thing. We have a lot more detail on the left than on the right, but it depends on where we're looking at it. Are we looking at the whole country, or are we looking at a neighborhood? And we have to adjust our data and our cartographic our map to show that. And there's a lot to that as well. The scale and the the different scales and the accuracy, and we talk about scale a lot in class. Here's a map showing, or not a map, it's a picture, in Boulder, Colorado, University of Colorado. Those are the flat irons there behind you. But this demonstrates visual hierarchy, which is another thing we talk about. The reader, the viewer goes through a journey when they see this. And when I see this, the first thing that I see is that White House in the bottom, which is, I think, the intent. And I see the house to the left, and I kind of sweep back. I see a road. I see, kind of a nice field, forested area behind it. And then I see the flat irons, and I got another hill there with a bunch of houses. And then, even behind the flat irons, those outcroppings of rock, another mountain range, and then the sky behind that. And so I've got 1, 2, 3, 4, 5, and then 6. And I come all the way back down to that bottom right to that house cluster down there. So I got like 6, 7 layers in here. And, probably 90% of the people that look at this are going to follow that same path. And that's part of what we do in making maps. Here's an example of that on a map. First thing you see is Cuba, but then there's not much there. There's not much information about Cuba. So roads or other, just the capital, but that's about it. So your mind is, okay, this isn't about Cuba, right? The land, it's about something else. And then you see the blue and you say, oh, okay. And then you read the text, right? Internal waters, territorial sea. And you say, okay, I see that. This is the boundaries that around Cuba. And then you say, oh, I see. Okay, then you got the United States and Mexico and Jamaica, and how that fits in with a larger, Caribbean landscape. And then I go up to the upper right, and I see the inset map. Great. And then I can kind of dig in a little bit more, and I see the purple maritime boundary agreement from 1977. And I didn't even have to go to the legend to figure any of this out. I was able to just work right within the map. And then if I want to have more information in there, I've got some text area where I can put text. So this is a visual hierarchy of a map. Here's another one. This is something we dig into during class. The one on the left, you can't make much sense of. The one on the right, the white lines match the white large text, and you see things first, like you see Lansing first, and then you see the black text, and then you see the smaller text, and then you say, wait a minute, there's white text in there, and what is that white text? And then you say, oh yeah, I see white lines, that must match that. And then you say, well, wait a minute, there's pink lines too, and I see some pink labels, the 3rd and 7th. And you say, okay, so that must match that. And our eyes and our brains can only really focus on one thing at once, right? We can switch, but we make things more prominent and less prominent by the colors and the choices and the size of the text, and lots of different things. And that's all part of the cartographic aspect of making maps. And then I see some major roads, but they're really faded back, and some streams and lake names, just for context. So again, visual hierarchy played out on the right and really not on the left. So, that's great. That's how, we design things, but we also need to understand our viewers' brains, and everyone sees the world differently, but there are some rules on how people, like sort of like we talked about with the visual hierarchy, how 90% of the people kind of work their way through. Our brains tend to work in very similar ways as well. So we have like linear corridor routes. When I make a map, or when I want to get from here to the nearest Dunkin' Donuts, I'll say, okay, I'm going to go to here to the next point, take a right, take a left, and usually I'll turn that right or left. In my brain, I think it's 90 degrees, might not be, but I know I need to do something at that point and turn. So we have these markers of meaning out there, streets that we know, buildings that we know, buildings that we could communicate. Yeah, the Dunkin' Donuts, or the Park Street T stop, right? When you get there, take a left, right? Stuff like that. So, we have these markers of meaning, and, we do an exercise in our class where I have the students draw a map of campus from memory. Usually start the semester this way. And it's something like this, right? 90-degree lines. They know certain things, certain buildings. Everyone has a different perspective. Everyone has a different idea of what campus is. So it's interesting to see these drawings come to life, and interesting to watch the students think. When I give them the assignment, they kind of roll their eyes and say, "Oh God, this is so easy. Come on, give me a break." And then half an hour later, they're like on their third version, and like, "What is that street name?" And they're like, "How come this isn't coming together?" And I'm like, "Yeah, it's difficult, right?" um, the idea is to take what's in their brain. I don't guess like Dumbledore pulling a thread of memory out, and getting it onto the paper. It's harder than it looks. Here is the London Underground map, the tube map from way back. I forget when, probably around the I'm going to say like turn of the century, 1900s, early 1900s. Showing the tube lines. Like, it's kind of nice, right? Like, an artist did this. Some good colors in there. You got some visual hierarchy. Get some reference stuff in the back. The tube map has expanded quite a bit since then. This is what it looks like now. So, if I said, "Hey, go from Gunnersby to, let's say, Wanstead," right? Go, right? Good luck, right? There's a lot of tracing going on. There's a lot of like tilting your head trying to figure this out. Like, it's complicated. But my engineer brain says, "Oh, this is nice. This is accurate. I can see where everything is in relation to everything else. I can see where the lines go underneath things, or if I'm, but this is too much." If you came across this in the tube station, you'd be like, "Wow," overwhelmed, right? Along comes a guy named Harry Beck. Harry Beck is a designer, works he's a planner, right? He's not an artist. He's a designer. Like, his job is to take what the engineers do and put that on a piece of paper, right? I worked my engineering firm I worked for. We had the engineers, the older guys, the experienced guys. They would do all the calculations, figure stuff out, scribble it on a piece of paper, hand it to the designer, and say, put this into a plan. And they would put it into a CAD format and make it look nice and translate what the engineer said. The engineer would come back, look at it, check it, and that was Harry Beck's job. Harry Beck decided to redraw the London tube map one day. He said, "This is confusing. I'm not doing this." And what he did was he did this. He turned everything into 90 degrees or 45-degree lines. He put everything on points. He didn't care about the reality. Everything is pretty evenly spaced out. And it works, right? It works because our markers of meaning play out here, right? So if I want to go to Gunnersby, which is here, and what did I say? Wanstead, I'd say, all right, I'm going to take this green line until I get to a point where I can switch to red, and that's right there. And boom, that was easy. And I'd be very confident that would work. You go back to this, and I said, "Oh yeah, okay, here's Gunnersby, here's Wanstead." Like, it's a little intimidating, like getting from here through all this tangle. Like, am I really going to get there? Yes, right, right. So, this revolutionized the way transportation maps are drawn. Every major city in the world, you see a map like this, because this guy Harry Beck had a different idea. They put it out there, and everyone's like, "Oh, this is great!" Like, because when you're on the train and the subway, you're not thinking about what's above you. You're thinking about what's the next stop, right? And this way, I can say, "All right, I'm on Gunnersby," and when I get to Wanstead, it's the one after Leytonstone. So if I see Leyton and Leytonstone, I'm getting close, and that's what I need to get off. And whether it's 30 seconds to that next stop or 2 minutes, I don't really care. I'm just going to be waiting to hear, okay, Wanstead, and you get off. So it matches how our brains work. So fantastic design. as evidenced by the fact that everyone uses it now. And even our Boston map is the same way. So interesting stuff. Love that Harry Beck. Guy with a new idea and did things totally differently, and we thank him. And then we have the latest technological capabilities. We have, as I mentioned already, piles of data coming through. The internet is collecting data about everything, and big data and all that great stuff. And things have changed, right? And we no longer just use maps on paper. We now have the computers and tablets and cell phones with internet connections, and that's changing the game as well. We have to change the way we present data, because we're no longer on a map and say, okay, here's the map. You don't know where you are. Now we have a blue dot that tells us right where we are on the map, and the map moves with us. Right, we're always at the center of the map. That's nice. But we can still zoom in and out, and still the same mental processes are at work, but we have better technology. There's more variables, so it's a whole nother level of complexity for us to deal with. We have scroll wheels, and we can pinch things and tap on the screen, and they couldn't do that with paper 30 years ago when I started this. And we have Twitter trends and Google information and Apple and Amazon. They all know who we are and what we're doing. And this is a map of New York showing the tweets that mention love or hate at any given time. Right, everyone seems to be a little happier in New York right now at this point, or whenever this was taken. But interesting to kind of watch that. Like, it's x-raying what the world is thinking and displaying it on a map, right? Like, whoa, a little bizarre, right? Here, the over here on the left is what the most common words that people are tweeting. That's powerful stuff. And what are we searching for in Google? And it's all geographic. This is showing cyber attacks in real time. Crazy. Everything is converging on the United States. If you played this, here's the earth wind, all the wind at any given time. Like, wow, what an amazing data set, right? Like, think of all the sensors that are working on this, and the satellites gathering information, and you can really teach earth science with something like this, right? Like, but there's massive amounts of data. The GIS system is putting this into this beautiful globe that we can see and make sense of, right? It's not just a bunch of column, the Excel database, the attribute data. We have a whole time element that we can work with now that we have computer screens, right? It's important. It's crazy. What else? We have shipping, global shipping. There's all the large ships have to have a GPS transponder sending out their data. Here it is. This moves at any given time. You can see where the ships are. You can see the shipping channels. You can see how things adjust over the seasons, winter and summer. You can go from year to year, see how many more tons of coal or gas or cars or automobiles, or you can filter them, you can color them. Like, just an amazingly powerful dashboard of data. And it's a map, really, right? That's and I love the yellow specks really pop out, right? Like, you got a nice background, you can really where you are in the world, but it's not the important thing. The important thing is the movement of those yellow dots. This is New York City, how it breathes throughout the day. Try to see if we can get that to work. Yeah, let's move on. I just want to Google that. You can see in the daytime, it's the red bars swell because those are showing people coming in, and at nighttime it goes out and it goes in and out, and it's just like, oh my God, it's like a living, breathing lung, of people coming into New York City. It really represents what's going on there really well. Here is stuff in space. These are the satellites zooming around, and you can click on any one of them and see where they are at any given point, or where it's going to be 2 weeks from now, and just gives you an idea of all the movement and all the stuff, all the metal that's flying around us that we use, and all this technology, and when it was launched, and all sorts of data. But again, it's data, it's a location, an X and a Y and a height element, and visualize on a nice globe here. Here's global trade movement, goods and services being shipped around. Again, similar simple globe pattern that kind of hides in the back, and the real point of this is to show those colored dots zooming around. Earthquakes, earthquake data shown by the height of that is the depth of where the earthquake happened. And this is pretty much real time, but you can look back, see where all the earthquakes were. Again, if you want to teach earth science and the ring of fire and global plate tectonics, like, what a great tool. Flight radar, you can track any plane at any given time online. Kind of neat. Here's one going from Boston to LaGuardia. You're tracking someone, you got to pick them up at the airport. It's great. Or even you're just interested in all the different planes moving around. Flight radar 24, another interactive map. And coronavirus tracker. This early on. This was, when I first put this slide in, it was like a year ago. So it was really just a Chinese issue back then. Has since spread a little bit. I'm sure you've heard about it. Anyways, we've all seen these coronavirus trackers. They're all maps, right? Think about it. They all have a location data. Not all of them, but the location certainly is a big part of the story. And then this other one called Windy. Everyone should check this out, windy.com. If you're at all interested in science, this shows not just wind, but all the rain and pollution movement and wind gusts and air, a couple dozen things that puts it up there, showing that data, waves, wind. It's really kind of cool. It's all interactive. It's really well done, and a great way to display science stuff. So as I move forward, trying to teach this, I'm rethinking my strict adherence to the rules of cartography, and that we got to get everything just perfect. Of course, I want to do that, but I'm looking more at how users interact with the data and the message we're sending, and you need to sort of get into more database management and almost programming and visualization techniques and JavaScript and SQL and Python. And these are the things that are moving my industry forward. So I'm preaching that to my students. And I need more Harry Becks. I need more people to say, hey, you know what? That doesn't work. I got a better idea. I'm going to do it that way. And trying to encourage that as well. Like, break the rules. Like, forget what I told you for this past semester. If you see a better way, go figure it out, right? Put it out there, see if the world accepts it, and you go from there. And there we go. Cartography, love it. Thank you for joining me. And I don't know. Thanks for joining me. I appreciate it.